Okay, so today it's all about energetics. This is a year 1 topic, so you'll be taught in year 1 or year 12. However, obviously, year 2s or year 13s will also need it. But anyway, so this is one of those topics where, yes, you do have to actually sit down and memorize some definitions, because as you'll see in a minute, without definitions, you might make some mistakes, okay, which I'm going to highlight in a second. Okay, so let's get on with it. Let's do this. So question number 1. This question is about energetics. Write an equation including the state symbols for the reaction with an enthalpy change equal to the enthalpy of formation for iron 3 oxide. So what's going on in my head is immediately I'm thinking, okay, well, I wish I'd memorized the definition for enthalpy of formation, because if I don't know it, then I might have a problem with this question. It says include state symbols, so I better include those. Okay, so now this is only a 1 marker question. However, a lot of people did not get that 1 mark. I mean, in the previous, according to the examiner's report, 1 in 4 people only got a mark. So that, that means 75% of the students actually didn't get this mark, and the simple reason is because almost certainly they hadn't realized what the enthalpy of formation means, and therefore they could not write an equation according to the enthalpy of formation. Yeah, simple equation, so let's start with that. Okay, so the equation for the enthalpy of formation of iron 3 oxide. Alright, so let's do this. So iron 3 oxide is Fe2, so obviously it's a product, so I'm going to write on that side Fe2O3. Now, if you don't know what iron 3 oxide actually sort of looks like in terms of the molecule, you need to go back to your sort of basics, GCSE basics, about how to decide what the formula is, okay, based on the name. Okay, so if a word name is given like this, what will be the formula? Okay, what does that Roman numeral 3 means, etc. Okay, I'm not going to go through it now. You need to do this, yeah. But if you can't do this, then you can't do this question. Okay, that's 1 mark gone. All right, so go back to your basics and understand how to write a formula from the name. All right, so that's the product. So iron 3 oxide. And then, of course, now this is where students often lost the mark, because then they said, all right, fair enough, we know it's iron, okay, and we also know, it's made from oxygen as well. Look at the oxygen, so it's oxygen as well. And of course, some students might have made a mistake of writing down one oxygen atom. However, it's a molecule, right? And they might have even start balancing it, and I'm not going to balance it because it's wrong. But anyway, they might start balancing it. They might say, okay, well, hold on. So 2 ions here, 2 ions here, and 3 oxygens. And then they said, well, how am I going to get 3 here? So what they could have done was, this is wrong, but what they could have done was 3 oxygens here, isn't it? So what do I need to multiply this by to get me 3? So it's obviously 1.5. So 1.5. Okay, but they know, well, you can't have half atoms, can you? So what you're going to do is they're going to sort of memorize. They're going to multiply everything by 2 to give you 2 here, 3 here, and 2 here. And that's what is wrong. Okay, and this is why, because it says enthalpy of formation. Now you should know the definition of enthalpy of formation is the enthalpy change when 1 mole of a product is formed. Okay, so if you start multiplying and giving me 2 moles here, or the examiner 2 moles, you have a problem. Okay, you're wrong. So this has to remain as 1 mole, because the question is asking you, yeah, for the formation or enthalpy of formation. Okay, so it has to remain as 1 mole. But then you've got to balance everything else to match that. And as it happens, okay, so 1.5 times 2 is 3, and that's fine. So that is balanced in terms of oxygens. Iron, there's 2 there, so obviously I need to put 2 there. Okay, and some students might have left it like that. Okay, they might have known the enthalpy of formation and might have left it like that. However, enthalpy of formation definition is the enthalpy change when 1 mole of a compound is made from its elements under standard states. Yeah, so from its elements under standard states. Now, iron. Okay, what is the standard state as an element? Okay, and don't forget, the question is asking you to include the state symbols. All right. So, for example, standard state of iron is solid. Yeah. Do not hesitate to use your worldly experience. Yeah. I mean, you know, iron. Iron is a solid. It's not a gas or a liquid. You've seen iron outside. Yeah. Iron nails and whatnot. Yeah. Oxygen obviously is a gas. Okay. Iron oxide. Now you might think, oh my God, I don't know what iron oxide is. Well, yes, you do. It's rust. Iron oxide, right? And rust is not a gas or it's a liquid. Rust is a solid. You know, that brown coppery type color. Yeah, when metal things, when you put them outside in the garden for ages, okay, and then it rains and it gets cold, and then and they start becoming brown and rusty. That's rust, iron oxide. So it's a solid, and that is the equation. Okay, including state symbols. I'm just checking. I've answered all the question, including state symbols. Okay, I've done it according to the enthalpy of formation definition. Okay, 1 mole of that. All right, 1 mark. Only 1 in 4 person got it. Come on, people, sit down and memorize the definitions if you want to get these easy marks. And this is an easy mark. This is not a difficult mark, as you will see. Okay, so let's do the next question. Table 1 contains some standard enthalpy of formation data. So my thinking is, I'm looking at the data, I'm thinking, okay, so they're giving me enthalpy of formation carbon monoxide and iron oxide, obviously. Okay, and that's the enthalpy of formation, kilojoule. Right, so they've given me an equation. Okay, the equation is the iron oxide reacting with carbon monoxide to give you iron and carbon dioxide. And they've given me enthalpy change as well. Okay, fair enough. They've given me enthalpy change for that reaction. Use these data and the equation for the reaction of iron 3 oxide with carbon. And here you go. So even if you didn't know, can you see what the formula was? You know, if you were clever and if you were thinking, right, you're thinking, oh, actually, can I just check have I written the formula correct? Fe2O3. And they're saying iron 3 oxide is Fe. Yeah, absolutely. Yeah, always, I know the pressure is difficult, but think about it. Okay, always have your sort of wits about you in the exam. Right, use this data and the equation for the equation of iron 3 oxide with carbon monoxide to calculate a value for the standard enthalpy of formation of carbon dioxide. So they want us to do that. Okay, enthalpy of formation, work it out. Show you're working. Okay, now when it says show you're working, and this is obviously thermochemical cycles you're talking about. Okay, so they've given me enthalpy of formation. Now the first thing I'm thinking is, okay, enthalpy of formation thermochemical cycle, what does it look like? Okay, so I know their thermochemical cycles are always triangles, aren't they? Yeah, so there's your reactants, there's your products, and there's something, right? And so what you end up getting is enthalpy of formation. That something is always elements. And of course, elements then form the reactants, and elements then form the products. Okay, because I'm talking about enthalpy of formation. If it was enthalpy of combustion, the arrows will be going down. Okay, but that's not this question. We'll talk about that. Again, learn basics like this, yeah? How to draw thermochemical cycles given the particular information. All right, so enthalpy of formation. So this is elements here. All right, so obviously they're saying show you're working, so I'm assuming they'll need me to either draw a thermochemical cycle or use an equation, but they want me to show them how I worked it out. As I've said before, I'm a visual person. I like sort of diagrams and pictures and things like that. So I'm going to draw a thermochemical cycle. So what I'm going to do is I'm going to copy that equation as is from the question paper. Okay, and state symbols 3CO, and then that goes to 2Fe plus 3CO2. And of course, state symbols, state symbols, state symbols, state symbols. Okay, and now thinking about this thermochemical cycle, I'm thinking, okay, well, they've given me enthalpy of formation data, right? So obviously, they've given me a formation of that, and they've given me formation of that. Okay, now what elements do I need to be able to make these? Well, elements I need is obviously iron. So obviously elements, so it's going to be state symbol is solid. Obviously I will also need oxygen, so oxygen is a gas. I will also need carbon, and carbon you can either put Gr for graphite, standard state, or you can put a solid. I think they'll accept both, but Gr is a better state symbol for graphite. And then of course I'm forming this from this, so the arrow is going to go that way. Okay, to form that. It doesn't have to be from all of them. I mean, you're just showing arrow going from all the elements to that, yeah? Arrow from the elements, forming that. Okay, and of course they want me to work out, what do they want me to work out? And standard enthalpy of formation for carbon dioxide. So they want me to work out that. So that means obviously that needs to be formed as well. All right, and now I've drawn the enthalpy cycle. It's not complete yet because now what I've got to do is I've got to transfer the data from the question, yeah, onto the cycle. All right, so enthalpy of formation carbon monoxide. Okay, carbon monoxide is -111. So I'm going to write down -111. But again, this is where your knowledge of definitions come in. Yeah, in this energetics topic, you've got to sit down. There's no two way about it. Sit down and memorize the definitions. Yeah, either using revision cards or whatever software you want to use. Yeah, but memorize the definitions, because enthalpy of formation of carbon monoxide means enthalpy of formation of 1 mole. But here I'm making 3 moles. What that means is that I need to multiply this by 3. Because I'm making 3 moles here. Okay, Fe2O3, enthalpy of formation Fe2O3 is -822, so I'm going to write that down, -822. All right, yeah, I can write down kilojoules per moles, but it's going to make it messy, but you should write it down. It's just going to make it messy now. Okay, so that's -822, and am I making just 1 mole? Yep, so I don't need to multiply that by anything. And that is what I'm trying to work out, okay? Oh, hold on, before I get to that, look at that. Yeah, yep, that equation here, it tells me enthalpy of that reaction. Okay, it's -19. So that I'm going to write down -19. Okay, and they've given me this enthalpy of the whole reaction, so I don't need to worry about multiples or anything like that. That is the enthalpy, yeah, of this reaction. Okay, now obviously they want me to work that out. Okay, so the enthalpy of formation of carbon dioxide. Now here's the problem though again. Enthalpy of formation means 1 mole, but I'm making 3 moles. So when I do find this answer, this will be the answer for 3 times enthalpy of formation of carbon dioxide. Okay, okay, so the way you approach this question, so that's my working out done. Actually, that's probably 1 mark. Okay, that's how you're going to get 1 mark. Let's start working it out. Okay, so I want to work this out. That means the way I think of it is, well, I want to go from here to here, but this road is blocked. Okay, there's a roadblock on the side. So the only place I can do, the only way I can do this is go the other way. Okay, so I'm going to go this way. However, every time I pass an arrow, so I've got to add up all the values, but every time I pass an arrow, if I'm going with the arrow, then I just do nothing, I just add them. But if I'm going against the arrow, as you'll see in one of the later questions, then I'm going to change these signs. Okay, so let's do this. So I'm going to add all of that. Okay, so I'm going with the arrow, so I don't need to worry about changing these signs. So it's -822 plus, remember, I'm adding everything, not changing the signs, I'm just adding everything. And then of course there's 3 times -11. Just taking that across. And then I'm going that way, and because I'm going with the arrow, I don't do anything with the sign, just leave it as it is, and just add that value. So plus -19. And all of that will equal that. So all of that will equal to that. But it will be equal to 3 times that. So it will be 3 equals to 3 times delta H F CO2. And so I work it out. So that equals -1174 kilojoules per mole. Okay, but remember it's 3 times. So now what I need to do is I need to find what is 1. So if that is the value to make 3 moles of carbon dioxide, what's the value to make 3? And it's a simple maths, isn't it? Yeah. So it's -1174 divided by 3, which equals -391 kilojoules per mole. Now, in this question, they have actually not asked you yet for the units because they've already put it there. Yeah, so I don't need to worry about the units. However, remember what I told you, yeah? I always say this, and I'm going to always say this, yeah? You need to impress the examiners, okay? Even though they've not put, units there, if you're going to write it here somewhere, the answer, it'll be worth putting down the units, okay? What's it going to do? Take another second of your time, okay? So just do it. So that is your enthalpy of formation of carbon dioxide, and that is your 3 marks, okay? So you're going to get 1 mark for that, 1 mark for sorting in arrow, values, and of course, yeah, and then you are going to get sorting values and actually getting that, you're going to get the third mark for the actual answer. Okay, so 1, 2, 3, 3 marks. Okay, okay, so let's go on to the next question. So the next question is, some enthalpy data are given in table 2. Okay, and immediately I'm thinking, hold on a second, they've not put enthalpy of formation, so what is it? Yeah, they're not put enthalpy of formation or combustion, so what enthalpy is it? And I'm thinking, okay, well, this is a simple, reaction. There's nothing seem to be happening apart from the reaction itself. But here, look what's happening. So it's going from nitrogen molecule to nitrogen atoms. So that means this is bond dissociation enthalpy. So obviously these are bond enthalpies we're talking about. And actually, look at the question as well. Yeah, I should have done what I tell you to do, read the question as well. Use the data from table 2 to calculate the bond enthalpy for NH in ammonia. So these are bond dissociation enthalpies. Yeah, so dissociation from H2 to hydrogen, nitrogen to nitrogen. Okay, okay, all right. So again, this is obviously a thermochemical cycle, but this is for bond enthalpies. All right, and it doesn't actually say show you're working. But how many marks is it worth? It's worth 3 marks. Okay, it's worth 3 marks. Okay, so therefore, I'm going to have to draw the bond, either the equation or the actual thermochemical cycle. All right, I might as well because it's worth 3 marks. Okay, so here we go. So I'm going to do this here. So this is now question C, and now again, I always write the main equation horizontally. Yeah, in a thermochemical cycle. Yeah, anything else I have to write, I can write on the other side. Yeah, but the main equation horizontally. Always start with that. So I'm just going to copy that equation across the top one. Remember what they want me to do. Look at that. They're saying bond enthalpy for NH bond in ammonia. Okay, in ammonia, and obviously they'll want me to draw this thermochemical cycle. So let's just write it down and draw it. So again, remembering the state symbols. Just good practice, I know. Okay, and that I might as well copy across the enthalpy of that as well. Bond enthalpy of this reaction, minus 92. Right, so this is a bond enthalpy cycle, okay, or thermochemical cycle of bond enthalpies. So the question then becomes, well, what goes here? Well, if I'm breaking these bonds, what do you think will go here? If I'm breaking your molecules to give me atoms, surely atoms will go here. Okay, so this is atoms. And of course, when I break the nitrogen atoms, I'm going to end up with a nitrogen atom. And of course, one molecule gives me 2 nitrogen atoms, and it's still gases. And one hydrogen molecule gives me 2 hydrogen atoms. However, there are 3 molecules of hydrogen, so therefore it'll be 6 hydrogen atoms. And is there anything else? No. Obviously, remember, this is balanced. Okay, and actually, what I've not done is here, coming back to this, is, and I know I didn't need it for this question, but again, I'm trying to impress the examiners. Okay, so I would actually balance these to match the equation. Okay, now you don't need to balance these with this and that side of the equation. If that equation is balanced, then all you need to do is balance that with one side, yeah, and it should be balanced with the other as well. So all I'm going to do is balance that with one side of the equation. So there's one Fe, so obviously there's 2 there, isn't it? So I need to put 2 Fe's, 3 oxygens, and there are 3 oxygens. That's 6 oxygens, but there's 2 there already, so I'm going to say 3. And then of course carbon, there are 3. Okay, good practice. Okay, I missed that earlier. Here we go. Right, coming back here, so I'm balancing it here, 6 hydrogens, so that's balanced, and I know this equation is balanced, so it's not a problem. Now this is atomization, so I'm coming from the nitrogen to the molecule to the atoms, hydrogen to the atoms, ammonia, atomization. Yeah, so I'm breaking them down into atoms. Okay, let's copy across the actual other, more information from the table. So nitrogen going to nitrogen atoms plus 944. So that going to that is plus 944. Okay, atomization of 1 molecule of nitrogen. I'm only atomizing 1 molecule of nitrogen. Don't start looking at that, yeah, because that is the number of atoms. This is atomization of 1 molecule, which is 944, and there's only 1 molecule here. Atomization of hydrogen here, okay, is 436 plus 436, but there are 3 molecules. Okay, and of course here I'm going to get the atomization of enthalpy of atomization of ammonia but there'll be 2 times. Why? Because I'll be atomizing 2. Again, now, working it out. So there's my sort of enthalpy cycle, okay, thermochemical cycle. Now, and that'll get you 1 mark. Now I need to work it out. So again, I want to go from here to here. Okay, so what I want to do is I want to go from here to here. However, that road is blocked. So what I'm going to do is I'm going to go that way. Okay, so now what that means is, now do you remember what I said about arrows, with arrows or against the arrows? I'm having to go against the arrow here. So immediately I'm thinking, okay, I better change that sign, right? So I'm going to change that sign. Okay, and then of course remember I'm adding all of these values up. So I'm going to say plus, and then I'm going to say, am I going with the arrows? Yeah, I'm going with the arrows, so I don't need to do anything with these signs. What I'm going to have to do is just add them together. So 944 plus, and then remember 3 times plus 436 equals, and remember this will be 2, did I say, oh yeah, atomization, 2 enthalpy of atomization of ammonia. Okay, so when you work this out, you get 2344 positive kilojoules per mole, and that equals, 2. Now, I'm going to change this slightly now, because remember what I'm being asked. I'm being asked to work out the NH bond enthalpy. Okay, now if I atomize an ammonia molecule here, how many NH bonds are there? One molecule of ammonia gives you 3 nitrogen-hydrogen bonds, and if there are 2 moles, that means there are 6 NH bonds. So that means this value is when I break up 6 NH bonds. So when I dissociate 6 NH bonds, okay, because remember, yeah, they're asking for 1 NH bond. So what I do is bring that 6, divide that by 6, and that gives you equals plus 391. Kilojoules per mole. Okay, and that is the enthalpy change of an H bond. Okay, right, let's do this. Final question. Give one reason why the bond enthalpy that you calculated in part C is different from the mean bond enthalpy quoted in a data. Again, here again is a definition that you need to memorize. Okay, you need to understand what is mean bond enthalpy. Okay, mean bond enthalpy is the bond enthalpy taken from a range of compounds, or calculated from a range of compounds. Now, range of compounds might have NH bonds, but they're not ammonia. Yeah, they might be amides. Yeah, so there might be NH bonds, but from different molecules. So the answer, and it's only one mark, so the answer would be that the data book value is derived from a range of different compounds containing NH bonds, whereas this is just from ammonia. Okay, and that will give you a mark. Okay. The points that you need to make sure you understand in this type of a question, again, definitions, enthalpy definitions. If you do not memorize enthalpy definitions, you are bound to make silly mistakes. Okay, and you cannot make silly mistakes if you're looking for an A star. You want to be able to eliminate those silly mistakes, okay, completely, and do them in your dream. Do those kind of questions in your dream. Okay, a lot of students lose marks in here because they don't know how to extract information from the question onto a thermochemical cycle, yeah, onto this energetic cycle. They don't know how to do it. So what I did, extracting information and labeling it, they don't know how to do it. So this will need practice. What they'll do is probably put the arrows the wrong way, maybe. Okay, maybe put the values. The common mistake they're probably going to make is this 3. They'll forget to multiply it. This will only come through practice. Okay, so practice these kind of questions. Apparently 1/3 of the students didn't get a mark at all in this question last time it was set in the exam. You can't be one of them. And that last question, and this last question, okay, this question about mean bond enthalpy, a lot of students did not get the marks simply because they didn't know what mean Bond enthalpy was. And all that needed was sitting down, understanding it, and memorizing a little bit. Okay? Right. I'll see you next week. Bye. So you think you know how to do these questions, right? Wrong. You just become familiar with them. You won't actually know how to do them until you try them yourself. Try this very question. I'll put the question in the description below. Give it a go yourself. And if you can do it, then you can say you know how to do these type of questions. But practice some more, okay? To become experts at it. Because that's what you're aiming for, to become experts at these type of questions. And you can only do these by practicing, practicing, and practicing some more. Let me know what particular question you would like me to go through. And if you have any advice on how I can improve these videos, let me know. I'm all ears. And if you find these videos helpful, give me a thumbs up and consider subscribing. Okay? All the best. See you next Tuesday.